This is Rges, Algebra 1, Lesson 1.7, Solving Equations. We're continuing on with the idea we've already begun. First off, I'd like you to turn to the oral practice on page 29, and I want to step you through this together. They're asking, what is the transformation needed to solve the equation? So in the first one, A, I see that I'm adding 4 on the left side, the same side that has the variable, and I want the variable by itself. So I would do the opposite operation. The opposite operation of adding 4 would be subtracting 4. So for A, you would want to say subtract 4. B, add 3. C, divide by 2. D, when we're multiplying by a fraction, we want to multiply by the reciprocal. So you would say multiply by 6. E, add 5. F, multiply by 3, because 3 over 1 is the same as 3, the reciprocal of 1/3. G, divide by 7. H, subtract 7. I, add 7. J, subtract 1. K, multiply by 4, the reciprocal. And L, divide by 8. So I want you to be that proficient with it. Practice it if you need to. Hopefully that is very clear to you. Now the next section is something where Algebra 1 students often get confused. What is the difference between an equation and an expression? An equation has an equal sign. An expression does not. It does not have an equal sign or an inequality sign. So in other words, it doesn't say less than or greater than, less than equal to or greater than equal to. It just is an expression full of numbers, variables, and operations. So remember, this is important because only equations can be solved. What can you do with an expression? Well, you could simplify it, or you could substitute a value I give you, or the book gives you, like evaluate it if x equals 7. You would do a substitution and then simplify until you get a single value. So looking at M, is there an equal sign? No. So that is an expression. N is an equation. O is an equation. P is an expression. You see what I'm doing? I'm just looking for the equal sign. Q, expression. R, equation. S, expression. T, equation. U, expression. V, equation. W, equation. And X, expression. You can only solve a what? You can only solve an equation. To be able to find a number for an expression, I must give you the value for the variable. All right, so now we're going to do some transformations, or some solving of equations, showing the transformation step. I'm going to model 2 through 12 for you, because this is a very important. I think that many of you have done this before, but I want you to get very proficient and very accurate quickly. So we do not begin with an equal sign here like we did when we were talking about expressions, because I already have an equal sign. I have an equal sign right there. So do not do that. Instead, you want to get rid of the 8, the subtract 8. Because I want to end up with something that says x equals with my number over on this side. So I think, what is the opposite of subtract 8? Add 8. Do it on both sides of the equal sign. Here I'm imagining a barrier right here going down the page where the equal sign is. Okay. So then, go ahead and put a line in there, and minus 8 plus 8 cancels out. Why? Because I'm doing the opposite sign. If you had 6 and you added 8 to it, you get 14, and then if you subtracted the 8, you'd be back to the 6. So on the left side now, I get x equals, and 13 plus 8 is 21. Circle the answer. Okay. Also, you could check it mentally by plugging it in. I'm thinking in my mind, 21 minus 8, what does that equal? Well, that equals 13. Number 4. X plus 9, I'm going to show you a couple ways to do this, equals 21. Remember, you do not start with an equal sign on the next line. That's very important. It shows a flawed thinking. I'm dealing with equations, not expressions. But the opposite operation, the one I need to do to undo the plus 9, is subtract 9. So I could write it all horizontally. I could say x plus 9 minus 9 equals 21 minus 9. This is perfectly acceptable. These again, plus 9 minus 9, cancel each other out. I'm left with x equals, what would that be, 12. 12, again plugging it in, 12 plus 9 is 21. Next one, you may also do it this way. 6x equals 72. Now it does say show the work, okay? But I'm happy, I'm modeling 3 different ways you could do this. I'm happy if you say, what do I need to do? As we were doing it mentally up in the oral practice above, I need to divide by 6. So you could just put a divide by 6 over there, showing me that's what you're doing mentally. Remember, it will undo the multiply by 6. I'm going to be left with 72 divided by 6, or 7. Plugging it. Wow, 72, that is not. Try that again. 72 divided by 6 is 12. There we go. Okay, plugging it back in, 6 times 12 is 60 plus 12 more, or 72. When you're confident of your answer, circle it. Now, reviewing just a minute, what have I done? I've shown you 3 ways you can legitimately do this. You can do your transformation on a second line, and then I'm putting the line underneath, meaning now I'm going to, as though I were doing vertical addition or subtraction. Okay. I could add it on the same line. That's a minus, not an equal. 9. Or I could show my mental step, my transformation step, over to the right of the problem. I tend to like to write less, so I'm very happy with this step, and that will move you naturally into more of a mental approach. But whichever approach you're most comfortable with, you must write something showing me what you're doing. Okay, let's keep going. Number 8 says 1/5 x equals 23. What do I have to do? Multiply by the reciprocal, which is multiplied by 5. Okay, showing me my step that I'd have to do to both sides of the equation. I would get 115 more. Okay. If I were to divide 115 by 5, I would get 20, and divide 15, 23. So that indeed is correct. Number 10, x minus 17 equals 8. Again, you can choose which method you're wanting to show, but some way or other you have to show me what you're thinking. I'm going to tell you I'm going to add 17 to both sides. I might not want to circle it. Put it in parentheses over there. Okay. Showing me my thought process. 8 plus 17 is 25. If I were to mentally check it, 25 minus 17, well, 25 minus the 10 would be 15, minus 7 more would be 8. 12, x minus 45 equals 89. My mental process, again, would be what? It would be to add 45. That's a 45. And I'm left with x equals 129, 134. You can do these kinds of problems with scratch paper or whatever if you can't do that quick addition in your head. Checking it again, 134 minus 5 be 9. Right? And then 12 minus 4 is 8. Okay. Skipping down to 42, to undo this, you would multiply by the reciprocal. Let me show you why. If I said 3 halves x times 2/3 equals 6 times 2/3, putting it on the left side of the equation and the right side of the equation. Now the 3's would cancel out. This is why it works to multiply by reciprocal. The 2's will cancel out, and I'm left with 1 times x, or x equals. Notice that 6 times that, I could think in terms of 6 over 1 times 3, or I don't have to. I could think of just this as a whole number, but the whole number gets multiplied by the numerator. That would be 6 times 2, or 12/3. Do not leave it in a form like that. You must be able to simplify it. 3 goes into 12 4 times. Another way I could have looked at that, let's look at this a little more carefully. I could say 6 over 1 times 2 over 3. 3 goes into 6 evenly 2 times. And notice now all I have to do is multiply 2 times 2, or 4. Either way, I tend to prefer to do fractions and canceling over here, but whichever makes you more comfortable. Number 44, another example, 4/5, x equals 20. If I'm thinking it in my head, I want to multiply by 5/4. And so on my next line would look like this. X equals 20 over 1 times 5 over 4. Divide 4 into 25 times. That's a 5. 5 times. And x equals 5 times 5, or 25. Checking it out, I plug it up right in here. At this x here. And I would cancel. 5 goes into 25. 5 times 4 is 20, and 20 equals 20. So you keep working on those problems as you do your homework and bring back any questions.